So if you recall, before we learned this lesson today, if I gave you a problem like this, oops, wrong number. If I put you, I gave you a number like this, like the square root of 9, everybody automatically knew that that would be a 3. And then before this, before today, if I gave you a problem like the square root of -9, I told you that there was no real solution, and you would either have told me that it's the empty set or you can't do it. But today, we're going to learn how to find the square root of -9. So the way that we're going to do this is, first of all, you're going to memorize some facts here. You're going to memorize that I is equivalent to the square root of -1, and that I squared also equals -1. Now, the way that we're going to tackle these negative square root problems is we're going to break it apart. We're going to factor it. So I'm going to change this into 9 times -1. This is going to be my step on all the problems when I see a negative number under the root. Now, over here, we just are learning that the square root of -1 is I. So I would square root that and make it an I. And then I square root the 9 and I get 3. And I'm done. So this is how we're going to be dealing with negative square roots. Let's try the next example. So again, for the 16, we would break it apart into 16 times -1. Now, if you don't realize that 16 is a perfect square, you'd have to do the whole tree here. 4 times 4, 2 times 2, make your pairs of 2's, pair of 2's, 1 comes out, 2 times 2 is 4. But I'm hoping at this point, when you're breaking down those positive numbers, you're going to be quick enough where you can find the perfect squares that are in there. So the square root is 16. So if I go back over here, is 4. The square root of -1 is I. So the answer to this problem is 4I. Let's try the 70. So again, you're going to break the 70 apart into 70 times -1. And then from there, I would try to factor the 70. 70 is just going to be 7 times 10. And even if I break the 10 down, I get 2 and 5. Notice there's no pairs here. So I can't break the 70 down. So the only thing here that I can square root is the -1. So this would become I square root of 70. You can't break the 70 down. Let's try the 48. I'm going to break it first into 48 times -1. The 48, I'm going to try to break it down, and I can actually factor it into 16 times 3. Now, let's say you did 6 times 8. If you did that, you'd have to keep breaking it down, or even 4 times 12. But your goal here is to break it down like we've done in the past until it's in simplest radical form. The only thing new we're adding here is that the square root of -1 is I. And then I can square root the 16 and then put the radical 3 behind it. So generally you're going to see your answers written with whatever number comes out, then the letter I, and then the radical. Technically, the order doesn't matter, so if you happen to see it on a PSAT or an SAT and it's rearranged, just know that they're all being multiplied. But generally, that would be the format you would see it. Let's try another example. 36. So again, we're first going to break it down into 36 times -1. Again, you should all recognize that 36 is a perfect square. It becomes a 6, and the -1 becomes an I. For the 15, again, break it apart. 15 times -1. Only factors of 15 are 3 and 5. I can't make a pair, so the only thing I'm going to be able to square root is the -1, and then put the radical back because I can't break the 15 down. All right, so for the 500, we're going to break it apart into 500 times -1. And now I need to try to factor the 500. I can break it down into 100 times 5. And again, if you realize 100 is a perfect square, let's square root it, square root the -1, and leave the 5 underneath. Now, if you need to keep breaking them down till they're prime, you can do that. However, it's not really necessary if you recognize the perfect squares. Now, the next example is a little different. It's got a negative sign outside of the square root. So all that's different here is this negative sign is going to be out in front of our answer. I'm going to break the -80, just like I've been doing, make it +80 times -1. I'm going to break the 80 down, 16 times 5, and then I'm going to square root. Square root of 16 is 4. Square root of -1 is I. Put the radical 5 back, and now I'm just going to take this and write it behind my negative sign. So if there's a negative sign outside of your radical symbol, just put it down, just drop it down in front of your answer. Now for the next one, again, we're multiplying a radical by itself, so you should recognize that it's just going to become -7. Now don't get confused and think you're going to do negative times negative is a positive. The reason behind that is this. If I were to break this down into, sorry, that should be a -1. If I were to break the 7s into 7 times -1 and 7 times -1, if I square root the -1s, it turns into an I, and leave the radicals there. If you recall from the first slide, or one of the first slides, I squared equals -1. So now if I multiply this back, I have a pair of 7s, so the 7 comes out, and then I times I is I squared, and I squared equals -1. So then I change the I squared to -1, multiply it, and I get -7. So if you recognize that you had a pair of -7s, know that the radical just disappears and the -7 comes out. Don't multiply it and think negative times negative is a positive, because that's what's going to happen in my next example. I need to break this down into 6 times -1 and 10 times -1. Now, I can do this two ways. I could actually factor this, or I could multiply it and then factor it. So let's just go ahead and break the 6 down. 2 times 3, I have the -1. 2 times 5, and I have the -1. So now I've got a pair of 2's, and that just comes out as a 2. The -1s become I's, and then the 3 and the 5 stay underneath. So now this becomes I squared. I can multiply these back, and again, remember I squared equals -1. So this would become -2 square root 15. Common mistake, students are going to do -6 times -10 and think it's +60. You have to break down and bring out the i's. Okay, so this is a negative answer. Yes?
Could you leave it -2 square root 15, or does it have to be 2i squared square root 15?
You have to break it down to -2 square root 15.
All right, so you have to leave it.
Yes, you have to simplify the I squared.
All right.
Everybody good? All right, let's try another one. Yes.
Okay.
All right, next
So the answer would be -2 squared.
one. Again, I'm going to do the same thing. I'm going to break the 20 into 2 times negative 1, and the 2 into 2 times negative 1, the negative 2. So again, this is going to become I square root 20 over I square root 2. Now, at this point, I can divide those positive radicals and get a square root of 10. I can also simplify the i's, and they become 1s. And then 20 divided by 2 is square root 10. Now, you could have also factored out the 20 and made it 4 times 5 and got 2 radical 5. But keep in mind that we can't leave that radical in the bottom. So if you can divide the square roots, do that to get rid of the radical in the denominator. Otherwise, we have to rationalize. Let's try the next one. Again, I'm going to try to factor it, but first let's make the 48. 48 times negative 1 over 24. Now, normally I'd be breaking the 48 down and to get some perfect squares in it, but I'm going to break my 48 into 2 times 24. Everybody with me on that? So then that way it'll cancel. Or if at this point right here you saw this went in here once and 2, you can also do it that way before you even factor it. So then now my final answer here, I have the negative 1 under the radical. Square root of negative 1 is I, and then the 2 stays underneath. So after you break apart the negative part and pull the negative 1 square root, then you could simplify or reduce the positive roots. Let's try the next one.
You just did it like that, I square root 2.
All right, for the next one, again, I'm going to break it apart into 5 times negative 1 and 15 times negative 1. I can pull the negative 1 as an I. I'm going to break my 15 into 5 times 3. Notice you got a pair of 5s, so one of those comes out. I multiply the i's, I get I squared, and then the 3 stays under the radical. Simplify the I squared to negative 1. Multiply that, and final answer is negative 5 square root 3. Again, common mistakes students are going to make. They're going to think negative 5 times negative 15 is positive 75, and then they're going to end up missing the negative sign. So just be careful. Let's try the next one. Again, we can make it 70 times negative 1 and 7 times negative 1. So this would become I radical 70 over I radical 7. I can simplify this, make this a 1, make this a 10. And then my final answer here, the i's cancel, and I just get square root 10. The next one, break the 40 apart. Again, normally I'd be tempted to break them down, but I'm going to just factor the 40 into 20 times 2. Or, better yet, we could even simplify it right where it is. Either way. So here, cancels. Square root of negative 1 is I, and the 2 stays underneath. So if right here at this step, if you'd rather make this a 1, make this a 2, and then just square root this to an I, you can also do that. So the final answer there is I radical 2. Next one again, break it into 12 times -1, 6 times -1, all over the square root of 8. So again, I could make those i's, the -1s, change into i's. And here I'm going to get an I squared. If I multiply the 12 and the 6, I get 72 over 8. Simplify, make this a 1, make this a 9. I squared is -1, square root of 9 is 3. Answer here is -3. Now, you could do these different ways, like you could have factored it, pulled it out, you could even rationalize it, however you want to simplify it. So in this case, it was almost better for me to multiply the 12 and the 6 and get 72. But again, you could have factored and canceled also. Now the next 3 examples are going to be very important to us as we're going to be learning the quadratic formula this week. And when we simplify the quadratic formula, sometimes we're going to get a negative number under the square root, and we have to break it down. So what I think I should do here is I'm going to just break down the -128, and then I'm going to put it back into the problem. So let's go over here to the side, and I'm going to break down the -128. Again, I'm going to factor it into +128 times the -1, and then I'm going to break the 128 into 64 times 2. And again, right away I can see 64 is a perfect square. I'm going to change that to an 8, change the -1 to an I, and then the radical 2 stays. So now let's put it into the problem. I'm going to take this out, and I'm going to put this in its place. So now I have -8 plus 8i radical 2 over 4. Now, common mistakes, everybody pay attention to this because people are going to do this on the test and the quiz, is right away people think they can simplify just the -8 and the 4. You need to remember that this 4 in the denominator needs to be able to simplify with both terms on either side of that plus sign. So you need to wait until after you break down the radical before you try to simplify. So this simplified answer, I can simplify it now, and the 4 becomes a 1, the 8 becomes a 2, and this 8 becomes a 2. So my final answer here is going to be -2 plus 2i square root 2. Same thing on the next one. I'm going to break down the -18 first, then I'll put back what I've got, and then I'll try to reduce. So again, let's break down the -18. First make it +18, then -1. The 18 I can factor into 9 times 2. And then I get 3i square root 2. Now, some students may end up factoring the 18 into 6 times 3, but then you're going to have to keep going. Again, you want simplest radical form here. All right, so now, again, I'm going to take out the -18 and put this in its place. So I'll just rewrite 17 over here. So 17 is now going to be -9 plus 3i square root 2 over 3. I'm going to try to simplify. This becomes a 1, this becomes a 3, this becomes a 1. So final answer here is going to be -3 plus I square root of 2. Do not be tempted to simplify this first. You will get the answer wrong. Oops, what happened to my 2? All right, number 18. So again, I'm going to break down the -50 first. positive 50 and negative 1. 50 breaks into 25 times 2. Again, if you're going to do 5 times 10, you're going to have to keep going. Square root of 25 is 5. Square root of negative 1 is I. Root 2 is left behind. Again, I'm going to replace the negative 50 with what I just got. So number 18, I have 5 plus 5i square root 2 over 10. I'm going to simplify now. This becomes a 1, a 2. Final answer, 1 plus 1i radical 2 over 2. You don't have to put the 1 in front of the I. So next we're adding two, like a real part and an imaginary part. Now, the instructions in your homework are going to say to write it in A plus BI form. And what this means is you're going to put the real number that doesn't have the letter I, and then you're going to put the term that has the letter I. So when I go to add numbers that are complex, I'm going to add the real pieces together. So the numbers that don't have an I. So 3 plus negative 2 is 1. And then I'm going to add the imaginary parts. And then I get negative 4i plus 6i, and I get 2i. So it's just like adding variables, like combining like terms. Treat the I like a variable. Same thing on the subtraction. The only thing here is you have to distribute the negative sign. So this is really going to turn into 12 minus 5i minus 8 plus 3i. I now add the reals. So 12 minus 8, and I get 4. Add the imaginaries, negative 5 plus 3, and I get negative 2i. So when you add and subtract, just treat them as like terms. Just remember for the subtraction to distribute the subtraction sign. Let's try a FOIL question. No. All right. So that's all we're really doing here. Did I skip one? Next one, we're going to FOIL. So again, just treat it like a variable. So we would do first and get 6. Outside, 8i. Inside, negative 9i. And last, negative 12i squared. Now, at the beginning, I told you that I squared equals negative 1. So anytime you get an I squared in your problem, we're going to change this to negative 1. So when I go to do my problem, I'm going to drop the 6. I'm going to add these two guys in the middle. So 8 minus 9 is just going to be negative I. I'm going to change the I squared into negative 1. I now need to multiply this yellow part. Negative 12 times negative 1 becomes positive 12. Drop the 6 and the minus I. And one last step, I can add 6 plus 12. So final answer is 18 minus I. Next one, common mistake. People are going to think they can just square the 4 and square the 3i. But again, remember, a binomial squared means to write it twice and FOIL it. So I'm going to write it 2 times. First, 16. Outside, 12i. Inside, 12i. And last, 9i squared. Everybody with me on that? All right, now, I still need to simplify this down. Remember, I squared this thing right here equals -1. So I'm going to do 9 times -1, and this will become a -I. I can also add my blues, and I can get 24I, drop down to 16, and now I can add 16, maybe I should do this in red, 16. So now I can add these two. 16 minus 9 is 7 plus 24I, and that's your final answer there. The next part is again, another FOIL question. This is leading us into number 24, and these are both conjugates. And in this case, because it's imaginary, it's a complex conjugate. But again, I'm foiling. When we FOIL a complex number or complex binomial with its conjugate, the outer and the inner are going to cancel. So again, this is just like the radicals where all I have to do really is first and last. But I'm going to do the whole FOIL process. So I'm going to do first and get 36. I'm going to do outside and get -30I. I'm going to do inside and get +30I. And then I'm going to do last and get -25I squared. When you multiply something by its conjugate, the outer and the inner, these two middle terms, cancel. The 36 will come down. Again, remember, I squared is -1, so I'm multiplying -25 times -1. I'm going to add it, and my final answer here is 61. Next, we're going to multiply something by its conjugate. So again, remember the conjugate is opposite sign. So it's a subtraction sign. So I'm going to change it to an addition sign. And now I'm going to FOIL both the top and the bottom. Now, again, remember, for the denominator, really all I have to do is first and last. But I'll do the whole thing out for you. So for the numerator, first gives me 15. Outside gives me 3I. Inside gives me 10I. And last gives me 2I squared. Let me go ahead and simplify this thing down. So again, for the green, it's 2 times -1. So 15, the blue becomes 13I, and the green becomes -2. I'm going to add the ends, so I get 13 plus 13I. Let me FOIL the denominator. So again, first is 25. Outside is 5I. Inside, -5I. And last, -I squared. Notice the outer and the inner cancel. I'm left with 25. And again, remember, I squared is -1. So this really turns into 25 plus 1, and it's 26. So now, here is what I've got after I FOILed. I can simplify this. I can either factor 13 out, or I could just say 1, 1, 2. So my final answer here is 1 plus I over 2. If you prefer to factor a GCF out, you can do that and then simplify it that way. Either way. Number 25, again, just like with radicals, we can't leave the letter I in the bottom of a fraction. So what I need to do here is rationalize this. So I'm going to multiply the top and the bottom by the letter I, and I get 3I over I squared. Recall that I squared is -1. So then I get -3I. I divide it. Okay, the last thing from this, and then there's some more at the end. Okay, so for this one, when I ask you to figure out what I to some power is, there's going to be 4 answers that you could get. So if on the test you blank out, I would guess either 1, -1, I, or -I. So whenever you raise I to a power, these are your 4 options for answers. But I'm going to show you which one, how you would get it correct. So again, there are different methods out there. There's like a compass thing where you can figure out and divide it by 4. But the easiest way I'm going to do is I already know that I squared equals -1. So I'm going to break this into an I squared problem. So I'm going to divide this by 2. Now, when it's odd, I'm going to have an extra I. So 15 divided by 2 is really 7.5. So I'm going to do 2 to the 7th power, because 2 times 7 is 14, and then I still have 1 extra I to make it to 15. Okay, so then now I know that I squared is -1. When a negative number is raised to an odd exponent, the answer is negative. So this would simplify to -1, and then I'm multiplying that by I. So -1 times I is -I. So I to the 15th power is -I. Let me do another one. Let's do an even exponent. Let's do I to the 16th. So again, if I divide that by 2, I get 8. Again, when you raise a negative number to an even exponent, then it becomes positive. So I to the 16th power is equal to 1. Now, remember negative exponents? Remember, it turns it into a fraction. So I'm going to move the whole thing underneath a 1, make the exponent positive, and now I have to simplify I to the 3rd. So again, I'm going to break it apart into an I squared times an I, because remember, you add exponents when you multiply. And then if you recall, I squared is -1 times the I, and now I have 1 over -I. I can't leave an I in the bottom, so I have to rationalize. So I'm going to actually move this negative sign to the top, and now I'll rationalize. I over I get -I over I squared. Again, I squared equals -1. So -I divided by -1 is now positive I. So these simple little problems really turn pretty intense. So let me try another one. Oh, now we're back to just practicing some other things. So the same stuff we did. So let's go ahead and let me distribute. So this becomes -4 minus I minus 2 minus 3I minus 4 plus 5I. All I did was distribute that subtraction sign and then drop the parentheses. Now I'm going to go back and add all my reals and add all my imaginaries. So all of my reals here are -4, -2, -4. When I add all those up, I get -10. Then I'm going to go back and get the imaginaries. -I, -3, positive 5. So this gives me just plus I. So the next one I'm going to FOIL. So I do first, outside, inside, and last. Again, remember the I squared becomes -1. So this last term turns into a positive 6. Drop down the red, combine the blue, and now add -8 plus 6. So then this would give me -2 plus 16i. Next one, write it 2 times and FOIL it. 2 plus I, 2 plus I. So here, first, outside, inside, and last. Drop down the red, add the blue. Remember, I squared turns into -1. And now 4 minus 1 is 3 plus 4i. Here we go again, foiling, multiplying by its conjugate. First is 36. Outside, 24i. Inside, -24i. And last, -16i squared. Again, I squared is -1. So this becomes positive 16. The blue becomes nothing. And the red is 36. Then I'll add these two and get 52. For this next one, I'm going to FOIL this first and then distribute the -5i. So I'm going to go ahead and do this first. And then I'm going to distribute the 5. Do not try to distribute the 5i first, the negative. You have to FOIL first, order of operations. So this becomes first is 16. Outside gives me -12i. Inside is -12i. And last is positive 9i squared. And then we still have this thing. So let me go ahead and combine my like terms first. So I get 16 minus 24i. And this becomes a -9 because 9 times -1. Okay, so the final answer here is we'll go ahead and combine the 16 and the 9. So 16 minus 9, 7 minus 24i. Over here for the I raised to the 25th power, again, I'm going to break it down into an I squared. 25 is odd. Closest I can get it would be 2 times 12, which would be 24. And then one more I makes it 25. Again, simplify the I squared to a -1. -1 raised to an even power is going to be positive 1 times I. So the answer here is I. Couple more examples with the I's just to get a little bit more practice in. And again, there are different ways that you could simplify the problems with the I's, but we'll go ahead and just do them, changing them to an I squared. So again, the 26, I could actually break it down into I squared raised to the 13th power, because 2 times 13 is 26. Again, change the I squared to a -1. My exponent is odd, so this simplifies to -1. Remember, when you raise a negative number to an odd number exponent, it's negative. If it's an even number exponent, then it's positive. For the 27, I can break the 27 into an I squared times 13, and then one more I there, because just like the problem above, I squared raised to the 13th is 26, and then one more I here. So here again, I would get -1 to the 13th times I. This would be -1 times I. So final answer here is -I. For the I to the 32nd power, again, I could break this into I squared raised to the 16th. And that's going to be -1 to an even power. So that's +1. Again, remember, a negative exponent is going to turn it into a fraction. So I'm going to put it underneath the 1. And now I can break the I to the 10th power into I squared raised to the 5th power. This becomes -1 to the 5th. And again, I get a -1 when it's an odd. So 1 divided by -1, and this answer is just -1. And here is your homework for the lesson. You're doing numbers 17 through 41. This EEO, every other odd, for example, starting at 43. So if I list the odd numbers here, just put a couple of them up here. Every other odd starting at 43 would mean you would do 43, skip 45, do 47, skip 49, do 51, skip 53, oops, and this is a 55, and then keep going. So that's what every other odd represents, and you're skipping number 81. So this concludes your lesson on complex numbers.